to YouTube, and now it's recording. All right. Right. It's possible that that's it.
He gave me a list of all these two.
I can't read this. 5 remotes to work a TV. Source, maybe.
Oh, it's starting to get worried because I didn't see you. And I was like, why isn't she here? Let me know if I.
One of the, since there are 3 of these, maybe it's this one.
My dad is.
I liked it better when it said, it was computer.
And whenever we talked about the traffic, he knows something I love Julio.
Fix the problem. Okay. I did get 21. Anybody else have trouble on 21? Okay.
Oh, yeah.
We started it. We started it and got stuck. The 2 that I promised to look at were number 14 and number 21. Number 14 was to confirm that what I thought was the answer actually was the answer. This is, without the red marking, this is what the solutions manual had. They did have the 5/3 out front, which is what I thought I saw the first time I did the problem. But without that 3x outside the radical, that is not arc-secant. And so I was pretty sure the solutions manual was wrong, but without phoning a friend, what's the only way that you can prove your answer's right? You differentiate and see if it gives you back what you started with. And it was a little bit ugly to differentiate because here's the formula for arc-secant. It's not u squared minus 11, it's u squared minus 1. And so it took me a few minutes to get the derivative to work out, but then sure enough it did. So I'm confident that that 3 is not supposed to be there. You have your du 3dx here, and then the 3 here balances it out and is what you have to have in order for that to be arc-secant. All right, so what we had in class was right. What I had done the night before was wrong. And I can think of one other place I need to change that before I forget. Number 14. Okay, I fixed it yesterday. So don't do that again. All right, and then number 21. Number 21, let's just start it again. I did it last night. There it is. All right, 21. Tell me what you're thinking. Any idea you have, and we'll try it.
The first thing I think was separated into
Okay. I didn't think to do that first, but I did have to do that, which I did later. Yeah, so let's go ahead and do it. I think that's smart. If we break that into the antiderivative of x over square root of 9 minus x minus 3 squared dx, and then plus antiderivative of 5 over that. All right, that absolutely works.
I took the 5 up front, and now it's just 5 times the
Yep.
arc sign.
Yep.
I didn't know what to do with the first time.
Okay. That's arc sign if you see u being what? X minus 3. And then du would be dx. And you also need an a. Your a is what? Is 3. So I like the idea of working on this one, keeping every line equivalent to the line above it, but kind of finishing this one before I worry about that. I like that idea. Don't forget the square root. That's kind of important. All right. So we're going to take one more step here. 1 over the square root of a squared minus u squared is arc sine of u over a, which is 3. And that's half the answer. All right. What about this other guy? Anything to try. It can't be the same u and du, or I'm not going to get that other x.
I tried folding the x minus 3 squared,
Okay.
and then just basically simplifying everything in the bracket, but it gets ugly because it's not mathematical.
I can see going down that road. I can also see it getting horrible.
I don't know what to do.
Yeah, and it might have still worked, but it is going to get horrible, and there is something easier. So, anybody have a different idea?
I took the denominator and put it to like the negative 1/2, just to have it all on the same line.
Yeah, I don't know what I would do with that. It's legal. I can't think of it being helpful.
I figured maybe it would see something.
Well, that's what you do. You know, you try what occurs to you. Splitting it apart, and we use that right here, or use substitution. And we haven't gotten to that. That's today. So I don't think it's this one because we haven't gotten to it yet. Oh. That's what I'm thinking. That's what I'm thinking. If it can't be, you can't be this, or I'd have to have another. I couldn't have that x in the numerator. Now, what I could do, if I want to do a formal substitution, I could say x is u plus 3, and I could put u plus 3 in place of that x. So that's one possibility. If I wanted to let x still be, no, that wouldn't work well. I like Michaela's idea. If this doesn't work for my u substitution, which I didn't do formal u substitution because I didn't rewrite that in terms of u and have to resubstitute at the end. That's what formal means. Yeah, let's see. If I let u be that whole radicand, 9 minus x minus 3 squared, then what is du? Negative 2. I'm going to keep the x minus 3 in parentheses. I don't know why, but, or, yeah, doesn't matter. I'll go ahead and do what you said. Negative 2x, wouldn't that be plus 6? Okay, plus 6. Or I'm going to just have it both ways so I can see which one I need. That's the same thing, whichever way you write it. And then dx. All right. So how was that helpful? What can I do with that information? I could multiply that by, you know, what, I think we're doing what we started yesterday in Paramount. Shoot, we are, and it's going to get us ugly. If I just put a negative 2 in the numerator with that x, then I can balance that with a negative 1/2 outside. But then what? I still need either the plus 6 or the x minus 3 in parentheses. Yes. And if I add 6 and subtract 6, then I'm going to have to break this one into 2 integrals. There's something, and there's no way that I would have expected this to occur to you at the beginning, but instead of breaking that 5, or breaking that numerator into x plus 5, what if right away I had seen, you know what, I'm going to need a x minus 3 here. No, I'm going to need a, let's see. I could have split that 5 to begin with if I had anticipated it. If I need an x minus 3 in parentheses, then I could have split that 5 into x
plus 3 plus 2.
Or minus 3 plus 8. Let me show you what that does. Do you agree that this is equivalent? Ooh, I'm sorry. Y'all tell me to zoom out if you can't see the whole thing. You agree that this is equivalent to what's on the line above it? Yes. Now that I already have the x minus 3 that I need, this 1/2 thingy is all I'll have to do. Because I already have that x minus 3. Oops, which that is not. I already have the x minus 3. And now that negative 2 times x minus 3 with the negative 1/2 in front of the integrand is equivalent to the line above it. And that's easier than the first way we were going to go, which would have given us 3 integrals. So that's something to keep in mind. Maybe instead of splitting right off, you can say, what do I need this to be, and what would that have to become in order to be equivalent to the line above it? If I need an x minus 3, then what do I add to the minus 3 to get the 5? 8. And that would have done it. Without changing this very much. So now that is negative 1/2 times the antiderivative of, if I want to do formal substitution here, what is the denominator. U to the what? Here's U. That's U to the negative 1/2. So 9 minus x minus 3 squared to the negative 1/2. And then beside it is my du. This is u to the negative 1/2, and that's du. So how would I integrate? Just u to the negative 1/2. Power rule. Add 1 and divide by, let's see, add 1 and the exponent would become 1/2, which I'm going to just go ahead and write as square root of 9 minus x minus 3 squared. And then divide by 1/2 is the same as multiply by 2. And so that coefficient would just become negative 1. And then to get another 550. Yep. Yes, ma'am. Can we celebrate this one first? Like we need a little, yay, we did it, before we move on to something difficult. Okay. Well, something else difficult. We need to celebrate this victory. I need
celebrate this one.
I need a Hershey kiss before I move on to the next one.
Would that, something like that be on the test? Because that
Okay,
would never
you
hurt.
have known me for what now? Something like 14 months? What do you think the answer to that question is?
No, but I just
Right.
have to make
You
sure.
just want to hear
so I
it.
can sleep at
That's
night.
so you can sleep at night. That would have to be the whole test because that would have taken, a good 30 minutes.
It would have never occurred to me.
But-
Like, it may have after like 2 hours.
But you know what, Michaela? That has been the case many times. Like when we were trying to figure out the formula for integrating secant tangent or secant. Who would have thought? Well, obviously, multiply secant plus tangent over secant plus tangent. So a lot of things would not have occurred to me, but once I've seen it, I can keep it in mind. Oh, I remember one time I had to split the 5.
Okay.
Okay, so I've celebrated now, Miss Samantha. Which one did you say? 17. My celebrations are just very small, so small you can't even see them.
That's the rules of
All right, so any ideas? Yeah, that's your first thought because you got a U out here and then a radical something beside it. But in order for that to be the U, then what are you saying? What's your best guess at what U might be?
I wasn't sure, so I took the square root of x and I put it in the other radical as like square root of x minus x squared. Does that make sense?
Yes, that does make sense. And it's possible that you could do it that way, but doing that way would actually require completing the square, which we haven't talked about yet. Yeah. That tool may work that way. I don't think it's necessarily the easiest thing. Ms. Michaela, what were you thinking? Tell me.
I believe the square root of x,
Holy cow.
and that would be the original of the other is 1 square root.
Oh my gosh.
Or 1 over 2 square root.
And A is 1.
Yes.
Okay. Maybe on to something. This would be a square root of an a squared minus u squared if u was the square root of x. let's see, if u is the square root of x, or x to the 1/2, then du would be x to the negative 1/2, which would put x to the positive 1/2 in the denominator with yeah, I was trying to come up with the words for one. 1/2 x to the negative 1/2, and there's the 1/2, there's the x to the negative 1/2. All right, so that's what I'm thinking. I may not have to do a formal substitution, but I at least needed to write that out to the side, and I can see that if I call this 1 over square root of x, if I want 2 square root of x instead of 1 square root of x, that's not equivalent to the line above it unless what? Yeah, that was dividing by 2 when you put a 2 in the denominator, multiplying by 2, and that's still equivalent to the line above it. All right. So that's A, or that's A, yeah, A is 1, and U is square root of X. So that is A squared minus U squared. And which one of our formulas has A squared minus U squared?
That would be arc sine.
That would be arc sine? Yes, it would. And I may not even, how did I think that 2 right there? It's so that I could write it as 1 over A squared minus U squared times du, where du is this dx. The step that I really need to do is separate the thing I'm integrating from its du. I need that even more than I need formal substitution. So that I can see, oh, I'm not integrating the 2 square root of x really, it's just the du that has to be there in order for me to integrate this. And so now that's 2 arc sine u over a, which would be what? Square root of x over 1, which is the square root of x. How about that? We would have looked at that x and said, well, obviously, I mean, Michaela would have. Michaela would have. All right. The only new tool we have to get today is completing the square. So if somebody wants to see one more homework problem, we can do it. Yes? Okay. I like it when it's unanimous.
I know what
33.
to do first. It talks about it.
Integral from 0 to 1 over square root of 2. Why don't we just call that square root of 2 over 2?
Because,
I don't know.
yeah.
Yeah. There we go. Arc sine of x over square root of 1 minus x squared.
I noticed that when I looked at this, it's the arc sine should be out to the second. It's 1 over the square root of 1 minus x squared, and the derivative of that is arc sine of x.
The derivative.
Or one of those two is that they're derivative of each other.
Yeah, I definitely recognize a relationship. Is it this is the derivative of arc sine, or arc sine is...
One of those two.
So if we just say arc sine x, then the derivative, if we call that our u, then 1 over square root of 1 minus x squared dx is our whole du. Yeah, what do you do after that? Do we have a formula for integrating arcsine? Do we have a formula for integrating u? What is the antiderivative of u? Yeah, 1/2 u squared. That's it. Just helps me to write that down. That's just u. This is the antiderivative of u du. How about that?
1/2 arcsine squared.
As long as you have the arcsine x in parentheses, it's ugly. The antiderivative of ugly is 1/2, same old ugly, squared. Well, yeah, it's the definite integral, so we have more to do. But again, if you're unsure, how can you be sure that that's correct? Differentiate it. If I gave you 1/2 ugly squared and said differentiate that, you'd say 2 times 1/2 is 1, same old ugly to the first with the derivative of the ugly beside it, and by golly, that's what we have on the line above it. Yeah. Because you think, I don't have a formula for integrating arcsecant. You're right, you don't. Or arcsine. You're right, you don't. But you have a formula for integrating u. And if it checks, it's right. That's the bottom line. If it checks, it's right. So, I don't need the plus c since that was a definite integral. I just need to integrate it from, or evaluate it from x equals 0 to x equals square root 2/2. All right? Can we not finish it? Is that okay? You're just training your eyeballs to see something that they've never had to see before.
I already can't see that one.
Okay, let's do completing the square, and then if we have time, that'll be the first if we actually don't run out of time. But if we have time and you want to see another homework problem, we'll do it. I'm trying to think if there's a better something I can do for a homework grade. I don't want to just not take up homework because potentially you could have 100 to average in with your other test, and that's really helpful.
You should take up data.
Take up homework on a 3-day delay. Assign it 1 day and then take it up. You know, I could do this. Say every Thursday I'm going to take up Monday's homework or Tuesday's homework, and that way, yeah, yes. Let's consider that. What if I say right now? Do you have your, let's say, 5 homework with you? If it's not something you keep with you, I don't want to take it up. I can take up 5. I meant 5-7. Oh, 5-7. No. Okay, then let's just say Monday I'm going to take up all of 5-8.
Okay.
And I want you to have a day to go home and fix things, because it's going to be like this all semester. It's going to take more than 1 day to get it. Okay, don't let me forget. Monday I'll take up 5.8. Okay, all right. Completing the square. Y'all tell me, since I'm recording this especially, tell me if I don't have my paper centered where you can see what I'm working, or I'll just be recording blank paper. That's not helpful. All right, completing the square. Keep those 3 tools in mind when you have a rational function. And what do I mean by rational function? It's a fraction. It's an algebraic fraction. One algebraic expression divided by another algebraic expression. So when I have that, I think it could be either a logarithmic integral if my numerator is one lower degree than my denominator, then it might be 1 over u du. If not, then it may be one of my inverse trig functions. If it's not one that just leaps out at me, it's obviously arc sine or arc tangent or arc whatever, secant. If it's not that, then start going through that list of tools. Would it help if I split it into two fractions? Would it help if I, let's see, second rule, split it into two fractions. What's my second tool in the toolbox? Oh, no. Well, that's the split it into two fractions. The first one's just u substitution. And so the third tool in the toolbox is completing the square. And it never would have occurred to me. I had to see how helpful it was in a couple examples to go, oh, that's a tool worth remembering. So, what about number 36? And let's just do the indefinite integral. Even though 36 is a definite integral, I know you know the fundamental theorem of calculus. Heck, you know the second fundamental theorem of calculus. So let's just practice. Oops, I said let's just practice the indefinite integral, and then I wrote down the bounds. They like the bounds, aren't they? Now, if I had not just prefaced this with, let's learn how to use completing the square, then you wouldn't automatically think, oh, obviously, let's complete the square. You would have said, well, if the whole denominator is u, then du is 2x plus 4, and there's no way to get that in the numerator. So it's not 1 over u du. And then I start thinking, well, maybe it's one of my inverse trig functions, but not in an obvious way. I don't have the square root of a squared minus u squared or u squared minus a squared. The fact that it doesn't have a radical makes me think, if it's any one of my inverse trig functions, which one does it have to be? It would have to be arctangent, unless somehow I'm going to get a square root in the denominator. I don't think so. But arctangent has to be in the form either a squared plus u squared or u squared plus a squared. Since you're adding, order doesn't matter. And I think, how do I get that to be something squared? How do I get, what's that when I'm trying to find the, say, center of a circle, and the equation something like that, and I want it in center radius form. I want a perfect square trinomial, one parentheses with a square outside. We completed the square to find the center of a circle. Maybe if I complete the square on the x squared plus 4x, well, I know I can factor it into perfect square trinomial. So how do I complete the square on x squared plus 4x? No, you're finding the vertex of a parabola. It's not an equation. I can't just make it an equation. Set it equal to 0. Yeah, what is that thing that I add to, you're close. Take half of, that's still the formula for vertex. You take half of b and you square it. Let's write it right here in the notes. To complete the square of x squared plus bx, you add half of b and then you square it. So what constant would complete the square on x squared plus 4x? Yeah, half of 4 is 2. 2 squared is 4. I'd need to add 4. Now, I can either add 4 and subtract 4. That's perfectly legal. Or I can just write that 8 as 4 plus 4. Either one. You're going to come up with the same thing either way. If I split that 8 into 4 plus 4, there's my perfect square trinomial. And I see now exactly how that's going to be arctangent. Sam's eyebrows just went, I'm glad you see it. That's my A. And when you're adding, it doesn't matter if you have u squared plus a squared or a squared plus u squared. Same thing. But in this case, the a is what? 2, and the u is x plus 2. And do I have the du that I need? Du would just be dx, so I don't have to do any hocus pocus there. That is 1 over a arctangent u over a. What a handy tool. That's a fabulous tool.
I just really use it.
Yes, that's going to be the hard part. All right. I'm thinking, well, tonight's homework's going to be easy. Like I've never said it.
I'm thinking you said that, and the next problem is going to be ridiculously hard.
It really isn't.
Oh, yay. Actually, they really
It's just scarier because of the radical.
That's true.
And because of maybe the negative coefficient. I absolutely could change that radicand to 4x minus x squared. To complete the square, I'd kind of like it to be in this form, though, the x squared before the x. What could I do to make that easier to complete the square? What do we have to do with a circle, for example, when we want to complete the square on the x's, but that's what we have. You factor out a 2. And so it might be helpful here to factor out a -1. I'm not saying you can bring it outside the radical. So you have an I in there somewhere. -1 times x squared plus or minus 4x. Add 4 to complete the square, and then ask yourself what would make that equivalent to the line above it. Go quickly and give them a subtract 4.
Oh, I hate that.
If I add 4 inside parentheses, but everything inside parentheses is multiplied by -1, I really subtracted 4. Yeah, just all you have to do is say, if I subtract 4, is it equivalent to the line above it? And the answer would be no, because you'd have -4 minus 4 would be -8. So just that's why checking yourself every step of the way is so important. Well, it looks weird for sure. Well, I'm probably not going to need that 2. So I'm going to go ahead and bring it outside the integral. But under the radical, I might could do this in one step, but I'm going to just do it in two to make it more clear. That is -1 times x minus 2 squared plus 4. And now I'm wanting to turn it around. And maybe it would have been fine to do that here. Something about it was messing with my head if I didn't have it in descending order when I tried to complete the square. If you don't, if that didn't bother you, then go ahead and flip it at the beginning. If that is 2 times the definite integral of 1 over square root of 4 minus x minus 2 squared dx, then which inverse trig function is that? Good old arc sine, where a is 2 and u is x minus 2, and I only need to write that down to make sure that I don't need to multiply by something in the numerator and divide by something, but the derivative of u would just be 1 dx, so I don't have to pull the old multiply by a constant, divide by a constant. So it's 2 arc sine of u over a. Plus, see if, oh, this wasn't one we marked up the boundaries. Yep. So on number 36, if we're playing like that's an antiderivative instead of a definite integral, I need to make plus c minus t. Maybe since we've been doing this for months now, maybe 20 minus 20.
I don't really know what it means.
I kind of probably break there.
I definitely
know.
forgot about it completely the second I walked out of the class.
Aw, that hurts my feelings just a little bit. Not really.
If I don't remember anything else,
That's it. Yeah, Cheryl's going to start by writing plus C and hoping she gets a point for that. Okay, last thing, unless we happen to finish this and do another homework problem. 48 and 50 on the notes, and you have 47 and 49 in the homework. We have lots of different tools for integrating now. How do we just look at various problems that actually look very similar, and figure out, can we integrate them? And if we can, how? We've got to think about all the different tricks up our sleeves. So what about the A part of 48? The antiderivative of e to the x squared. It's so tiny and cute, surely. Okay. Say that again.
Did you see e to the x is u and so
Oh, okay. I'm not going to write on this until we actually figure out what it is. You're saying u is e to the x, and so that's u squared. If u is e to the x, then what du has to be beside it? Oh, I'd have to have another e to the x. Maybe, I don't remember reading that, but it could have said that somewhere.
if we have e to the x, answer is e to the x, e to the x is e to the x, what have e to the x squared, and that's what we have.
Well, if I'm integrating
Or will it be
u squared, I have to have du beside it. And I have the u squared, but I don't have the du beside it. If this were e to the x squared times e to the x dx, I could absolutely do that. Okay, I'm still not, y'all hold on, I'm still trying to,
something weird. Because I was thinking like e to the x and e to the x was e to the x squared instead of e to the 2x. So my brain had a malfunction.
Okay, all right. So we tried something, it didn't work. Got any other ideas? No, it's cute.
No, I have what the ugly of the cuteness is against that. I don't think it
Okay, so you're saying let ugly be x squared? Yeah, it is an idea. Okay, so what if u is x squared, then du would be what? Oh, I could get a 2 there. I can't just randomly get an x there. Oh my gosh. I just thought, ooh. What if u was x squared, du was 2x, and I said x is the square root of u? I don't think so.
What does that mean?
I mean, if this is true, then that's true.
That is true.
But the question is it helpful? Then that would be e to the u. I don't see that being helpful.
Well, this doesn't look like a trig function. I know that much.
Yes, you're right. That is not arc sine.
I don't feel like there's like a logarithm thing that we're just not thinking of.
Can you think of anything else to try? The answer is no, we can't integrate that using one of the formulas that we know so far. Maybe we can later, but look what the question is. Just determine which can be done. Well, this one can't.
This is the kind of question on the test that would take me.
You can't use your phone on the test.
Sure, I can. Not on the test, but.
Well, that just confirmed. That just confirmed. I didn't think we could, and I tried every possible thing I could think of. I feel reasonably confident.
Ooh, you can do the next one harder than the next one.
Yes, the next two you can do. But this one, not using basic formulas is all I'm going to say. Not using what we know so far. Maybe there's a way to do it, and maybe we're going to learn it later, but using what we know so far, no, can't do that. What about the B part? If I let u be what? If u is x squared, then du is what? 2x dx. So either formal substitution or informal substitution, I need to write this as what? What am I integrating? Yeah, I'm not asking the question well. What is the function? I want the function I'm integrating first, and then its derivative beside it. All right, e to the u, which would be, if we're not doing the formal substitution, e to the x squared, and then what would I have to have beside it? 2x dx. And how do I make that equivalent to the line, or to the left of it? All right, and double check that this is e to the u, and this is du, and it is equivalent to what's before it. All right, if it is, then what's the antiderivative of e to the u? And do the same old u. It just helps me to write the function I'm integrating separate from its derivative so that when I get ready to integrate, I see, well, I don't have to worry about that anymore. It has to be there in order for me to integrate, but when I'm integrating, it's actually just e to ugly that I'm integrating. All right, what about C? Just very pretty mean. Can't do it? Like the A part did?
You said
Okay, so I've spoiled the surprise, but okay, if you can do it, what do you think you should be? Okay, ugly. Can't be the e to the 1 over x, or I'd have to have another e there as part of its derivative. So if u is 1 over x, then what's du? That's, you integrated instead of differentiated. That's negative 1 over x squared. You write it as x to the negative 1. Bring the exponent out front. Subtract 1 from the exponent. Negative 1 over x squared. And I have my 1 over x squared. I just need it to be negative. X to the negative 1. Bring the negative out front. Subtract 1 from the exponent. Is that okay now? Okay.
Yeah, I thought you said negative 1 x squared, and I was like, don't I have to be a negative 2? And I maybe over.
I might not have said it. Knowing me, what I wrote is not what I said. Okay, so I'm not going to do a formal substitution here, but I'm going to say in order to integrate it, what's the function that I'm actually integrating? E to the 1 over x, and to integrate e to the 1 over x as e to the u, I have to have du right beside it, and du is negative 1 over x squared dx. Now, if I don't have that in parentheses, it's going to look like subtraction instead of multiplication. Is that equivalent to the left? Not without that. So write down what you want so that you can clearly see the function you're integrating and its derivative beside it, and then figure out how to legally get it to be what's on the line above it. All right, what about a part of number 50? It kind of looks like which trig one? Yeah, it kind of looks like arctangent. 1 over 1 plus u squared. And so what would be the u in that case? X squared? Because x to the 4th is x squared squared? Yeah, but I could get the 2, but I don't have the x. I think that's probably what the b part is. Because if u is x squared and du is 2x dx, then I can write that as 1 over 1 plus x squared squared with the du beside it, as long as I make that equivalent to the line. I keep saying line above it, and I'm working up the line. Would that be equivalent to what's before it? Not exactly one.
Oh, wait, yeah.
Oh, yeah, that's equivalent to what's above it, or to the left of it. And now it is in the form 1 over a squared plus u squared. Well, I realized that what we were going to try to do on the A part was going to work on the B part, so I decided to just work the B part and then go back and see if there's anything else I can try on the A part. So what is the B part? What comes before the arctangent? 1 over A, but since A is 1 here, the 1 over A is still just 1. So 1/2 arctangent U over A, which is just 1 plus a constant. And the great thing is it's checkable. Okay. We only did B before A because what our first instinct was for A actually turned out to be the way to do B. So can we think of anything else to do on the A part? That's a terrible way to figure it out.
I think there's a way to get the X removed for DU. There's a way to get X. So.
Right. The only other thing that would have occurred to me to start on the A part is, well, what if the whole denominator was the U? But if the whole denominator is the U, what's the DU? 4x cubed, which is almost what I have in the C part. So I think we can do the C part, but not the A part. All right, so let's do the C part real quickly. If U is 1 plus x to the 4th, then du is 4x cubed dx. And what is the function that I'm integrating? Well, you said the x cubed is part of the du, though, so I'm going to write it out to the side. So I'm going to say, I'm just integrating 1 over u. This is 1 over u with du out beside it. And is that equivalent to what I started with? Not without a 1/4 out front. Is that equivalent to what I started with? Yes. So all I need to think now is, well, how do I integrate 1 over u? That's natural log of u. Actually, absolute value. Minus 10. Absolute value of u. I know, but guess what? That's not what it's going to say on the test. Those 3 problems are going to be number 7, 9, and 14 on the test, and the directions just say integrate, and you're going to go, can I? And if I can. I'm kidding. I haven't made it so I have no idea.
You should maybe 7, 9, and 14, 10, and 13.
We have never finished with 1 minute to spare before. Let me suggest that we have 4 more days to cover stuff before the test and then our review day, but only one of them is actually on the test. 5.9 is on the test, 7.1 and 7.2. We've got to cover them because we had to move that test, but not necessarily, or they're not going to be on the test. So it's really time to start looking at the practice test. The practice test, because this is a weekend and you have more time between now and Monday than you're going to have any other time. Actually, you've got 2 weekends before the test. That's good. But if you want to start looking at different kinds of problems mixed together, because just like when you learn to factor, that's the hard thing. You give me 10 of the same and I can make 100. You give me 10 different ones, much harder. So maybe start looking at practice test 1. Ooh, guess what we do Monday? Hyperbolic cosine.
Oh, that's why we
Hyperbolic cosine.
I know it's cosine.
See you, Sam. See you, Jordan. Miss Cheryl keeps ruining our surprises.
Well, I'm sorry, I like to read. I got nothing better to do. Read calculus for fun. Yeah.
Yes.
Is this the right practice test? Or is this
Um, It. I would say just look at momentum and see if it's the same or different.